Here's problem 927. Assume that the average mass of each of the approximately 1 billion people in China is 55 kilograms. Assume that they all gather in one place and climb to the top of 2-meter high ladders. The center of mass of the Earth would then be displaced how far? Well, let's imagine what we have here. Let's say we got the Earth, and let's place all the center of mass on the x-axis. So we have the mass of the Earth, and let's say it's located at some position x. It may or may not be at the center of the Earth, but we'll say that the mass of the Earth is at that position. We have all these people located on the surface of the Earth, and that's the mass of the people of China. And hence their location on this diagram, if we put the origin at the center of the Earth, their location is at the radius of the Earth. So if I were to find the center of mass of this two-mass system, I would say the center of mass is the mass of the Earth at x location plus the mass of all these people at the location of x equal to the radius of the Earth over the total mass of the system, which is the mass of the Earth plus the mass of the people. Okay, so far so good. Now, what happens if all these people climb 2-meter high ladders? Well, let's take a look at that situation. So now the mass of the Earth is still at its location. It hasn't moved. So wherever that location is for the total mass of the Earth, we still have the same spot. But now the people in China have all climbed ladders, and their new location, as far as this x-axis is concerned, is going to be the radius of the Earth plus 2. And that will represent the mass of the people of China. So this new center of mass, let's call it x center of mass prime, will be equal to the mass of the Earth times x plus the mass of the people of China, and now their new location is the radius of the Earth plus 2. All this over the center of mass, or the total mass of the system, mass of the Earth plus the mass of the people. Okay, the difference between these two locations for center of mass would be this: x center of mass prime minus x center of mass. And that's going to be equal to the mass of the Earth times x plus the mass of the people times the radius of the Earth plus 2 all over the mass of the Earth plus the mass of the people, and all this minus x center of mass, the previous center of mass. So that's the mass of the Earth times x plus the mass of the people times the radius of the Earth over mass of the Earth plus the mass of the people. Sounds good? So we have that the mass of the Earth times x and over the mass of the Earth plus the mass of people, those terms are going to cancel out because we have the same denominator, and those would cancel out in the numerator. Also, the mass of the people times the radius of the Earth, those terms will cancel out. So we're going to end up with just 2 times the mass of the people of China over the mass of the Earth plus the mass of the people of China. So that is our algebraic result for this. We actually have some numbers for this. So our center of mass is going to move this distance. That'll be 2 times the mass of the people of China. Now we're told that the average is 55 kilograms. So we have 55 kilograms, and we have 1 billion people in China. So that's 10 to the 9 people in, 10 to the 9 people in China over the mass of the Earth, which is 6 times 10 to the 24, plus the mass of the people of China, which is 10 to the 9. So what is all this equal to? 1.83 times 10 to the minus 14 meters. So it's going to shift the center of mass of the Earth people system by 1.83 times 10 to the minus 14 meters. Now, the size of an atom is on the order of an angstrom, about a half an angstrom, which is actually much larger than this distance. So this is really on the size, almost of the size of the nucleus of an atom. So all those people, 1 billion people, climbing 2-meter tall ladders in China would move the center of mass of the system a little bit more than the nucleus of an atom. Not very large, not much of a change, nothing to really notice. But that's our answer, 1.83 times 10 to the minus 14 meters.